China is on track to overtake the United States and become the world's largest air travel market by passenger volume sometime in the early 2030s. This means that in the coming years, the country will require an enormous number of new aircraft, especially wide-body jets, potentially numbering in the thousands. Yet Boeing now faces a serious risk of losing its wide-body foothold in China, particularly with the 787 Dreamliner. Why is this happening? And which aircraft is emerging as the biggest challenger to the 787? Let's break it down. When Russia first occupied Crimea and parts of eastern Ukraine, international sanctions began tightening. Suddenly, Moscow found itself in a difficult position. Isolated, cut off from modern Western wide-body aircraft, and unable to easily purchase or maintain jets like the Boeing 777 or Airbus A330. Russian civil aviation was pushed dangerously close to collapse on key long-distance routes. A logistical void opened between East and West, and filling it became an urgent national priority. But within that pressure, a rare opportunity appeared. Behind closed doors in China, the joint CR-929 project, now known as the C929, quietly took form. This wasn't just another commercial program. It was a multi-billion-dollar lifeline for two countries facing geopolitical pressure, combining China's financing and production strength with Russia's deep aerospace experience. Together, they aim to build a 280-seat widebody capable of competing directly with the Boeing 787 and Airbus A350. Yet this partnership soon revealed its internal tensions. By 2021, when the conflict in Ukraine escalated, the project began to unravel. In 2022, Russia officially withdrew from the joint venture, leaving the C929's future uncertain. Analysts believed Russian engineers had been reassigned to military programs, grinding core development work to a halt. Meanwhile, rumors circulated claiming China had insisted on full ownership of Russia's engine technologies, a demand Moscow refused. With cooperation no longer feasible, China's COMAC suddenly became the sole leader of the program. And that led many Western observers to question whether China could realistically carry the project forward on its own. But on February 24th, COMAC stunned the industry with a major announcement. The C929 had officially entered flight testing, built with fully independent intellectual property. Even more surprising, the aircraft had already secured its first order from Air China before the jet had even flown. According to company officials, their reasons for placing that early order were compelling, and not what most people expected. Before we continue, take a moment to subscribe. We have much more ahead, and you won't want to miss it. As soon as the first technical details emerged, opinions shifted dramatically. It became obvious that this wasn't simply a larger version of the C919. Beneath the polished surface was a true long-haul widebody designed specifically for ultra-long routes like Beijing to New York or Shanghai to London. With seating for around 280 passengers and a range of about 12,000 kilometers, the C929 stepped confidently into the same class as the Boeing 787 and Airbus A350. What really caught experts' attention were its materials and structural design. Over half of the aircraft is made from carbon fiber composites, roughly 4 times the composite percentage used on the C919, matching the high-tech construction of Western widebodies. Paired with about 15% titanium alloys, the C929 achieves a strong yet lightweight frame, reducing fuel burn and improving aerodynamic efficiency. The result is lower emissions and stronger performance, making the aircraft one of the most environmentally progressive designs ever attempted. This blend of lightness and strength is what gives the C929 its impressive 12,000-kilometer range, enabling it to connect cities on opposite ends of the planet without refueling. Its design choices also make it stand out. With a wingspan of nearly 65 meters, the jet actually exceeds that of the Dreamliner, requiring advanced aerodynamic shaping to maintain lift, stability, and performance. Inside, the cabin width of about 5.5 meters is wider than both the 787s and the A350s, creating a noticeably roomier space for long-haul flights. That extra width translates into broader aisles, less cramped seating, and a more open cabin environment. All crucial advantages on flights lasting 14 to 16 hours. COMAC didn't stop there. The C929 includes a highly digital cockpit, smart lighting features, and a flexible interior layout. Manufacturing the aircraft is a huge undertaking. More than 2.2 million parts, thousands of test assemblies, and an onboard health monitoring system capable of diagnosing problems mid-flight, a capability still missing in many existing airliners. Altogether, the C929 represents far more than just a new airplane. It's really China's declaration that it's ready to compete with the world's biggest aerospace producers. Air China echoed this sentiment when explaining their early order, calling it both a patriotic duty and a strategic investment in China's future aviation strength. As the country's flag carrier, Air China stated that adopting a domestically developed wide-body is part of its mission to grow into a world-class airline and help accelerate China's high-quality development in aviation. Despite all this progress, one question still lingers. Can the C929 truly be considered made in China? The skepticism is pretty understandable. COMAC emphasizes independence and technological self-reliance, but behind the scenes, the reality appears more complex. According to recent reports, this ambitious wide-body jet still leans heavily on Western technology. As noted by the South China Morning Post, the Chinese manufacturer has signed a series of deals with foreign suppliers, including a partnership with Safran of France to co-develop essential systems like braking and oxygen control, as well as contracts with Crane Aerospace and Electronics in the United States for cabin door sensors. In fact, among the 9 core avionics suppliers, only 4 are Chinese, with the remainder coming from overseas companies. On one hand, this reliance brings undeniable short-term advantages. By integrating proven Western components, COMAC can improve reliability, accelerate development, and align with international safety standards, crucial prerequisites for obtaining certification from EASA and the FAA, and for earning the trust of global airlines. Yet the other side of this dependency paints a much darker picture. The C919 is an example. By relying on Western systems, the C929 becomes vulnerable to geopolitical pressures and export sanctions, leaving its future potentially at the mercy of foreign policy decisions. A single shift in export rules could stall production, delay deliveries, and undermine China's narrative of technological sovereignty, the very message COMAC has worked to build. Most critically, without full intellectual property ownership of these core systems, the C929 cannot truly be considered a completely Chinese aircraft. Instead, it is a hybrid one-half belonging to China, the other still tied to the West. To some critics, it could even be seen as a copy of Western aircraft, just as the C919 once was. So while the C929 may symbolize China's growing ambition in aviation, the path toward genuine independence and toward Shanghai's dream of becoming a true aerospace powerhouse remains long and uncertain. But those doubts may soon disappear, and here's why. COMAC has effectively silenced concerns about its dependence on Western components through one revolutionary breakthrough. For years, that reliance had been a major vulnerability. When the West tightened export controls, it limited key parts for the C919, a narrow-body jet that was about 60% domestically produced, but still relied on an American-French engine. With the C929, however, China has made a decisive move to erase this weakness once and for all, taking full control of every critical technology, from the airframe to the beating heart of the aircraft, its engine. That heart is the CJ2000, China's first domestically developed high-bypass turbofan engine, and, honestly, a symbol of the country's technological awakening. This isn't merely a replacement for a Western engine. It is a statement of intent, designed to rival or even surpass the world's leading power plants. Initially developed for the C919, but delayed due to concerns over stability and certification complexity, the CJ2000 is now being reintroduced with the C929 as its testing platform, with flight trials scheduled for 2029. Should these trials succeed, China will cross a historic threshold, achieving complete independence from Western engine technology in commercial aviation, something even Japan and Russia have struggled to achieve. Technically, the CJ2000 is a monumental engineering achievement. It delivers up to 35 tons of thrust, matching engines like the Rolls-Royce Trent 1000 and GE Genex, but with remarkable efficiency. Its next-generation materials and cooling systems allow for higher operating temperatures and lower fuel burn, providing a 5 to 7% improvement in efficiency over comparable Western engines. For airlines, that means lower operating costs. For passengers, a smoother, quieter, and cleaner flight. Physically, the CJ2000 is enormous, featuring a 3-meter fan diameter and a total height of 4.55 meters. It even surpasses the 33-ton Genex engine used on Boeing's 787 Dreamliner. Its composite fan blades and advanced noise suppression technology make it not only powerful, but also one of China's quietest engines ever built. At cruising altitude, its fuel consumption is notably lower than many international rivals, giving it an edge in long-range performance. Capable of speeds up to 980 kilometers per hour, the CJ2000 blends raw power with refined engineering, strength, speed, and silence, redefining what a Chinese-made engine can achieve. For COMAC, this is both a strategic and symbolic milestone. The CJ2000 transforms the C929 from an ambitious newcomer into a formidable, fully self-reliant contender on the global stage. It dispels long-standing perceptions that China must depend on foreign technology for its most critical systems. Unsurprisingly, Western analysts now acknowledge the C929 as a legitimate rival to Boeing and Airbus, and the CJ2000 as the engine that could tip the balance. With its high domestic content, breakthrough propulsion technology, and the political momentum behind China's industrial ambitions, the C929 powered by the CJ2000 isn't just another airplane. It could reshape the future of global aviation. If the C929 succeeds, it could become the biggest disruption to the wide-body market in decades. With its long range, high efficiency, and breakthrough domestic engine, this aircraft stands poised to challenge the dominance of Western giants, especially Boeing's 787 Dreamliner, the very model it was designed to rival. For airlines seeking alternatives amid rising costs and geopolitical tensions, a competitive Chinese option could be transformative. And if COMAC delivers on performance, reliability, and certification, the C929 may not only win domestic loyalty, but also carve out a share of the global wide-body market, signaling that the age of uncontested Western dominance in long-haul aviation may finally be coming to an end.